Here's another interesting application of, again, unsupervised machine learning, clustering, rule mining kind of, applications. In this case, actually, we work with the Mall of America, which spent, close to $10 million on giving free Wi-Fi to anybody who goes into the mall. Okay, they did this in November 2015. And now what happens is, as people walk through the mall, their smartphone is designed to connect to the nearest access point. And because of that, if you then go into the log files of the Wi-Fi data, you can actually, and you can tie an individual to their mobile device, and you can trace their physical path through the mall. Okay. So now again, think about, there are millions of users who come in. We don't want to understand all these people at the individual level, but how about intelligently grouping these into maybe 6 or 7 segments based on like what time they come in, how much time they spend, which regions they go, and then, once you can do that, then you can think about all kinds of use cases for this, right? So the mall, for instance, may be able to tell a particular tenant, like a store like Macy's or Nordstrom, how much traffic of what type of customers they are able to drive, over a period of a month or on a particular weekend, right? And this might be useful, for future, like let's say lease renegotiations. You can think about, operational benefits from this, even just in terms of figuring out, how to schedule, let's say, janitorial staff to clean all the bathrooms in the different areas depending on where the traffic is. You can do association rule mining to think about, if when people go to, let's say, a sushi restaurant, do they also go out to high-end, designer stores, right? And that may be a subsegment that the mall really cares about. You can see response to, physical advertising that they do, right? So this is, in some senses, almost like taking, the kinds of analytics we could do on web pages, right? We could look at where you're traversing through the website. We can actually do the same kind of thing in a large physical space like a mall, right? So we can see where you're traversing through the mall out there. So really, really interesting use cases. Here is another, application of predictive modeling. A local hospital, Hennepin County Medical Center, essentially works, obviously to take care of lots of patients. They have to staff their different hospital kind of units with the right level of nursing care. And because of the contracts with the nursing union, they have to give nurses the schedule 4 weeks out. Okay. So this turns out to be now, the staffing decision turns out to be a very interesting forecasting problem, right? So you have to forecast how many people are going to show up in a 4-hour window 4 weeks from now in, let's say, the emergency room, right? And how many people will show up in the cardiovascular room, for instance, right? So this turns out to be, modeling of multiple, time series data. You can look at, the past census. You can think about incorporating factors like, are the events happening downtown Minneapolis? Are there, maybe the Super Bowl is coming in next year, right? Are there, weather patterns that change? For instance, how many people show up in the ER? So all these factors can then go into a predictive model to make forecasting decisions that then become an input into staffing. Another interesting application project that we did with a pharma company, where this pharma company is always trying to go out and buy new compounds, right? So they want to acquire another compound, maybe something that's becoming generic. But you want to, before you do that, as a CFO, you might want to model the risk. What is the likelihood that something could turn bad with this new acquisition, right? And with pharmaceuticals, one of the things that's always a danger is really adverse side effects, right? So it turns out that there are actually, the federal government, the FDA, maintains a publicly available data site. It's kind of like Yelp for pharmaceuticals, where anybody who has an adverse reaction can go in and type in a review about the drug, right? So this is, again, unstructured textual information about things that happen to them when they consume this drug. And the old way of going into, for this company, the old way of trying to get some insights about a compound with respect to adverse reactions was going to a consultant and waiting for a week, and each query was almost $5,000, right? But if you are actually really capable with doing some data engineering, in this case, the analytic solution was really a data engineering tool that looked at fuzzy matching of pharmaceutical compounds to their true spellings, and essentially now, instead of in the old way of going out and waiting for a week to get an answer from a consulting company, essentially the analytic solution around this is to create a little tool that does some pretty basic text analytics and fuzzy matching to find all the related things people are saying with respect to any compound that somebody enters, right? So tremendous value. In fact, in this case, the sponsor of this project basically said that every time they press that button in the tool, they save $5,000, right? So analytics can have huge value. We are seeing a lot of excitement around streaming analytics, right? The fact that people want to put sensors in machines, let's say in the shop floor, and these sensors, and this is kind of part of the whole IoT movement. These sensors are going to generate tons and tons of data, and we can go out and then apply machine learning to predict machine failure, right? And if you can do this in advance, then you have you minimize unplanned downtime, and for certain types of machines, this can be again hundreds of thousands of dollars, right? So think about let's say an earth mover that is an expensive piece of capital equipment. If you can learn from past patterns of the usage of this machine, and the different kind of sensor readings as to when something's going to break down, if that's happening, then we can go out and maybe do some preventive maintenance, right? So this is one of the best use cases of IoT that people talk about. Here's another example of different kinds of analytics, the world of online dating analytics. And a real fun project that I was recently involved with was trying to determine whether we should actually try what would happen if we actually reduced some of the information asymmetry in these online dating markets. Okay, so the atomic unit in this kind of in an online dating market is who likes whom, right? So this is really the fundamental piece of information that then goes out and actually matches people and goes out and creates value for the platform. And it turns out that the default setting on these sites is that users actually do not, for a very specific reason, which I'll tell you, users do not get to see who gave them a hot vote, right? So think about, maybe if you're on a mobile app using Tinder or OkCupid, you can, swipe left or swipe right, so you can say the person whether this person's hot or not. Or in the old kind of web-based system, you could give ratings to people on a 5 scale. And the reason these sites don't, actually reveal, aggregate ratings even, is that these are pretty harsh, right? So men are on average, 2.2 on a 5 scale. Women are about 3.3. So giving the overall ratings is actually not a good idea. In fact, the market might even unravel. People might be really, dejected by looking at, how quote unquote unattractive they are. However, what we can do, right, and we wanted to see what would be the effect of this, is what we could do is we could show some people, essentially, we could test the idea whether telling people who gave them a 4 or a 5 or a hot vote actually increases the overall efficiency of the market, right? This could happen by making people more confident. This could happen by getting people to engage more, maybe initiating more messages, right? So this is again, on the other hand, it could also maybe go the other way. In other words, maybe if you see that somebody's giving you a lot of hot votes, maybe your actual price goes up, right? And you maybe overestimate, or you get kind of cocky and you overestimate your ability to go out and get a particular date. And so if that's true, then in the data, this would actually be reflected in lower levels of engagement, like lower initiation of messages, for instance, right? So upfront, we can't really theorize which way this would go. How can we use analytics to solve this? Well, we can go out and run, an experiment where we can take 100,000 people, and 50,000 of them, we give them this ability to see the recent hot vote, right? And the rater is still being unaware that this is now visible. And if you can do that, okay, then again, you can causally examine whether reducing this information asymmetry actually has a positive effect on the market, as we would predict from theory, right? It turns out actually in this case it does, right? So overall, just to summarize, business analytics, we went through causal analytics. We took some examples of unsupervised clustering type of algorithms. We took some examples of predictive. We saw these being applied across a wide range of industries. We saw them being applied for all kinds of interesting questions. And overall, all of this comes together when you have really strong analytics leadership. So you need the executive level to understand what can be done. You obviously need the technical capabilities to do the data engineering and get the right data sets organized. You need to have the ability to do predictive and causal modeling. And all of this basically in every company that I've seen, runs as a team sport, right? So analytics, we keep saying, is a team sport. You got to assemble teams of business people, technical people, and data scientists together to go out and solve these problems. Okay, so hopefully this gives you a good perspective of applying business analytics. So have fun and good luck.